Focus sample. E-learning project would like to welcome all children to this lesson. I am Pavitra Bhattrai and I will be taking a physics lesson for Key Stage 5, that is for class 11 and 12 children. Welcome to you all to this lesson. I will be teaching you today about projectile motion. So let's begin with the term projectile. Basically, children have a notion that projectile means something that is sent in the space like a space shuttle. Let's make it more simple and interesting. Projectile simply means an object sent into space or thrown into space with the help of an external force. And what is motion? So motion is the part described by the projectile. Let's take a practical example, like in our school level, when you kick a ball in the air, a football, so football becomes a projectile here. So when we do so, we maintain an angle and we move it into the air. There are many examples. So if we cite some more, one could be during the basketball match when a player tries to score. He tries to shoot a ball. Have you ever wondered the path taken by the ball? Other than that, consider a football player kicking a ball in the air. This often situation leads to a similar condition where the path is very much similar, and that leads to what is known as projectile motion. So now let's define what is projectile motion. So projectile motion in short is any object or any particle sent to the space or thrown into the space or projected into the space with the help of an external force against force due to gravity. Okay, to cite some more example, I would like to play a small video to you all. Okay, so I have shown you a few examples based on projectile motion. You can think about some more example of your own, and that can be a part of your assignment too. So towards the end of the lesson, you can think about 2 examples of projectile motion on your own. So having looked into the example part of projectile motion, now we can connect the motion here. You must have observed that the path taken by the projectile is more of parabolic in nature. So if you have observed the examples carefully, you must have noticed that the path taken by the projectile is more of parabolic in nature. So in our lesson today, we'll try to focus on the parabolic nature of the path taken by the projectile. So before that, let's try to learn more on projectile motion. So first of all, what is projectile motion? Let's try to go back and think about projectile motion. So we have learned that it is an object sent into the space with the help of an external force against force due to gravity. So there are different types of projectile motion. So the first one being one-dimensional projectile motion. So what is one-dimensional projectile motion? So one-dimensional projectile motion means where we can trace the path in terms of a single variable. What does it mean? So here, let's take an example. Let's throw a ball in the air at an angle of 90 degrees. So we know what will happen. If you just try to send a ball or push a ball at perpendicular to the ground, then you will see that it will trace back the same path, which simply means there will change in terms of height only. That means the path will be a straight line. So, in such cases we can categorize the projectile motion as one dimensional projectile motion. Another example could be rolling a ball. So, when you roll a ball on the ground, it will just take a straight path. So, these all phenomena we get to see in every day. It is a part of our life, but hardly we can acknowledge it, especially in terms of games and sports. We use it now and then, but hardly children realize that it is a part of a projectile motion. Now, let us go to two-dimensional projectile motion. So, what is meant by two-dimensional projectile motion? Here, two-dimensional projectile motion refers to when we send a projectile or when we throw a ball at certain angle, what we notice is the path taken can be traced in terms of change in two variables. That means we can trace the path in a plane. That means in terms of change in x variable as well as y variable. So, such motion here we refer to as two-dimensional motion. So, we will try to focus more on two-dimensional motion, and we have already looked into the examples and we know the path traced by two-dimensional projectile motion is parabolic in nature. Okay, now let's go to the descriptive part of the projectile motion. So, consider a particle. Okay, let me draw two axes here, the x-axis and the y-axis. I want to trace the path of a particle that is being sent into the space with the help of an external force. Let us say this is the origin starting point here. So, let us say a particle is projected into the space at an angle theta with the velocity v. So, what happens? This particle, it will follow a path, it will rise up to a certain height, and then after some time, after attaining a maximum height, it will trace back the path. That means it will fall back to the same position. Now, what causes it to happen so here? So, basically we have sent the object into the space at an angle theta with a velocity, initial velocity v. So, in that process the path taken by the object is slowly it will rise up to certain height, maximum height, and then after that point it will start, the velocity of that particle starts dropping in the reverse direction. So, as a whole you can see in the diagram only, this is a parabolic shape. So, we can very well see that the nature of the path of a projectile is parabolic, especially two-dimensional projectile motion is parabolic in nature. Now, let us learn about this velocity here. This velocity v, initial velocity with which we have sent the object to the space, can be resolved into two components, that is the horizontal component and the vertical component. Now, what are these two components? This velocity can be taken as the sum of these two components. So, here the horizontal, if you want to find out the velocity along the horizontal direction, that will be given by Vx equals to V cos of theta. And what is the velocity along the vertical direction? That will be given by V sin theta. Okay, so what happens here? Let us draw a diagram here. Now, if you look at the horizontal velocity, it is constant. Look at the direction horizontal. The only force acting on the projectile in the process is the force due to gravity. Now, if you look at the direction, horizontal direction, the acceleration due to gravity has no impact on the horizontal direction velocity. Therefore, the velocity remains uniform. And what about the acceleration along this direction? It becomes 0. So, what about the vertical direction here? So, this velocity is exactly in the direction opposite to the acceleration due to gravity. So, what happens? You will notice that because of this force, here we can very well draw the diagram in each case at different position the velocity of the projectile. At this point you can notice that the height, the distance of the projectile rises at the cost of the velocity getting reduced. So, at this highest peak, this maximum vertical distance is what is known as the horizontal, the maximum height. Symbol we can either take as H or Y naught. So, here this peak, up to this peak point, what happens to the, at this point the distance is maximum, but what happens to the vertical velocity? It reduces to 0. Again from this point it starts increasing, but in the reverse direction. So, in this process we come across 2 to 3 new terms, such as one is the maximum height, another one is the total distance covered, the distance covered by the projectile, that is what is known as the range. First one being the vertical, the maximum vertical height, the vertical distance, what is known as maximum height. Second one being the range, and third one being the time taken to complete the flight by the projectile. That means the time taken by the projectile to complete the path. So, that is what is known as the time of flight. These all are categorized under what is known as projectile motion equations. So, how we can connect it? So, basically this is the concept behind. What we can do is basically we get this factors or these components to calculate in numerical problems. So, in the later part I will show you how to use a numerical problem in order to find any of these components. Apart from these 3 terms, the another most important is what is known as the path of the projectile. So, which I have already described, and I have already stated that the path of the projectile is parabolic in nature. So, no wonder the displacement will be taken into 2 different aspects. First one the horizontal displacement, and second one the vertical displacement. So, here the horizontal displacement, how we can calculate? So, in our lower grades we have learned how to find out the distance. Distance equals to speed times time. So, here how we can calculate the path taken by the projectile is u cos theta times the time factor here. And similarly, this is the path taken in the horizontal direction, the displacement in the horizontal direction. And what about the displacement along the vertical direction? So, that is actually what is given by the equation. Here we have as tan theta times x minus, that we have is as g divided by 2u square cos theta times x square. So, using this equation we can find out the path taken by a projectile. Now, look at this equation carefully. We have a factor x square here. And being mathematics students, we all know that it is a part of quadratic equation. It is not part, in fact it is a quadratic equation, and we all know the nature of the graph for quadratic equation, which is parabolic in nature. Now, having said this, let us try to summarize the key points, and let us try to learn the spatial cases in case of this 2-dimensional projectile motion. Now, look at this angle theta. You can project or you can set an object at different angles. Different angle means at 10 degrees, 20 degrees, 30 degrees, 40 and so on. That means the angle in between 0 to 90 degrees. So, what if for which angle? For which angle the distance travelled will be maximum by the projectile. Suppose I want to kick a ball and I want to hit the target. So, at what angle I need to kick the ball? So, in case of spatial cases here, you need to remember 2 conditions here. First one, suppose you are sending a ball from the ground, then the angle maintained has to be, theta has to be equals to 45 degrees in order to have the maximum range. Remember, range means the maximum distance covered, the horizontal distance covered during the flight. So, when you are sending a projectile from the ground, theta has to be 45 degree in order to have the maximum distance covered. If you want to throw to a greater distance, you have to maintain the projectile at an angle of 45 degree. What if you are standing and you want to shoot a ball? So, you are a little bit above the ground. So, what should be the angle then? So, in that case, case number 2, if you want to have a greater range, then you, in that case, since we have to consider our height also, we need to consider our height also. So, for that case, we need to shoot a projectile or an arrow at an angle less than 45 degree if you are sending the projectile above from. That means you are sending a projectile above the ground. There are 2 cases, you have to keep this in mind. First of all, you are projecting it from the ground. Second one, you are projecting it above the ground. There are 2 situations. Let me give you one example each. So, theta equals to 45 degree. Example for this one, when you are shooting a projectile from the ground, best example could be a football, because that is with respect to ground. Another good example could be space shuttle. That means when we launch a satellite, we do right away from the ground. Let's go to case number 2. That means when you talk about above the ground, projectile sent from above certain height above the ground. Like when you play games like javelin or discus. So, in order to have a greater range, what we can always do is, you can always aim the javelin at an angle little bit smaller than that of 45 degree in order to have the maximum distance covered. The children who are not aware of this technique, they try a different angle, especially during sports time. So, if you have this knowledge, I am sure that you are going to do pretty good. So, having learned about this concept, once again I like to repeat here. So, if you are sending a projectile above the ground, that means you have to aim it slightly lesser than angle, that is less than 45 degree. But if it is happening right from the ground, then it can be projected at an angle of 45 degree. So, can you think of some more example on your own? There are so many that we find around us. As I said in the beginning of my lesson, we ignore it. The things around us are part of physics, but we ignore it and we are far away from these facts. Now, the last concept I would like to let you know in this lesson is that sometimes you find that for 2 angles, the range is same. So, let me show you a picture here. So, when does it happen so? So, what do you notice is, when you project let's say this angle is 20 degree. You send a ball into the space at an angle of 20 degree. You notice that this is the range, the maximum distance covered by the object along the horizontal axis. Now, you notice that when you place a ball at an angle of 70 degree, you find the range is same. Now, how is that possible? So, this is what is known as complementary angle concept. So, what we get to know here is that, especially when the angle of contact is complementary angles, the range is same. So, what is the only difference? What can you see the difference in figure I have drawn here? That means the difference is only about the maximum height. And we can also talk in terms of time of flight here. We can say that when a boy kicks a ball at 20 degree and 70 degree, the difference between these 2 situations is that in the first one, the ball stays in air for a shorter period of time, whereas in case of the ball which is being shot at 70 degree stays in air for a longer period of time. So, this comes under what is known as the complementary angle concept. You have to keep in mind that, so the range is same when theta, when the angle is theta. So, when we can achieve this condition? When the angles are theta cos of 90 minus, this comes under what is known as the complementary angles. I hope you understand what is meant by complementary angles. So, complementary angles are those angles when you add up it makes up 90 degrees. Suppose for example 20 degree plus 70 degree, that makes up 90 degree. What could be the another pair? You can try out at your home. So, hope I have made clear with this lesson. Before I wrap up, I would like to mention here the key points I have sorted here, like the path taken by the projectile is, especially for 2D, is parabolic in nature. Number 2, we have learnt about what is meant by the horizontal range. Keep in mind, horizontal range means the distance, the horizontal distance, the maximum distance covered by a projectile during the flight. Then we have come across a term known as time of flight. Time of flight means the time taken by the object to complete the flight. First to rise to the highest level and to come back to the same projectile position. The third one is the maximum height. What is the maximum height? The maximum vertical distance achieved by the projectile during the flight. Apart from this, you may get in questions like calculate the time of ascent. Now, what is time of ascent here? Apart from this, time of ascent is the time taken by the projectile to reach this maximum point. That means it will be just half of the time of flight. So, time of ascent I can add here one more. So, what is time of ascent? Ascent, I hope you all know, ascent means to rise to certain height. So, that is just half of the time of flight to reach this point. So, half of this time of flight will be nothing but u sine of theta over g. Okay, having learned this, now let us try to do one numerical, simple numerical. Let us learn how to use these formulas. Okay, so here we have a follow-up activity, that is the question which we can work out here. So, the question we can read here: an athlete throws a javelin to a maximum distance of 80 meters. How long is it in the air? That means we are supposed to calculate the time of flight. And to what height does it rise? That means we are supposed to calculate the maximum height and neglect the height of the athlete. So, let us see, let us try to solve this question. Let me help you out here. So, I had the formulas written here on the board. You can have a look here. So, you must have how we can calculate the time of flight, or how can we calculate the horizontal range. These all are given by the formulas here. So, number 1, the horizontal range. We can use the symbol r here, is given by the formula u square sine 2 theta over g. Now, in the question, just see what all are given to us. We are given, we are given the range. The maximum distance here refers to range. Range is equals to 80 meters. Now, when we can achieve this distance, I have given you in my previous concept, case number 1. We can have the maximum distance achieved if we can send a javelin at an angle of theta equals to 45 degree. So, remember, theta is not given here. It is an indirect question. You have to read the question, try to analyze and try to find out the theta on your own. So, since they are talking about the maximum distance here, definitely, and we are asked to ignore the height of the person. So, we can take theta as 45 degree. Okay. So, we know we are given and we know g, value of g is 9.8 meter per second square. Let us try to substitute here in this equation. We are interested, we want to find out the time of flight, the maximum height. So, for that, first of all, we are not given initial velocity. So, first of all, let us substitute. What is range given to us here? R is given to us 80. We don't know the initial velocity with which the projectile is being sent, the javelin is being thrown. So, sine of 2 times what is theta? Theta is equals to 45 degrees divided by 9.8. So, 2 times 45 degree, that gives us 90 degree, and what is sine of 90 degree? That is simply 1 divided by 9.8. So, rearrange this equation. So, here unknown is u, that is the initial velocity with which your projectile javelin is being thrown. Cross multiply, after cross multiplying we get that u square equals to 80 times 9.8. So, we want to find u, it is a u square. So, how to get rid of square sign? Take root on both sides. So, u equals to root of 80 times 9.8. So, this should, please work on calculator, this should give you a value of 28 meter per second. That means the person is throwing the javelin at the rate of 28 meter per second. So, first we got is initial velocity. Let us find time of flight now. So, we already have equation for time of flight. So, let us substitute and get the result here. So, time of flight number 2. Time of flight, we use the symbol t, is given by the equation 2u sine theta over g. Now, remember u we have already calculated from our first part. We can substitute to get the time of flight. So, that is given by 2 times u is how much we got it as 28 meter per second times sine of angle is 45 degree over 9.8. I hope you all remember what is sine of 45 degree, that is 1 over root 2. So, therefore, we get the equation as 2 times 28 times 1 over 9.8 times root of 2. That should give us as, when you use a calculator, it should give you a result as 4.04 seconds. You can correct it up to 2 decimal figures. Now, the third calculation, we are asked to find out the maximum height. So, we already have a formula here to find out maximum height. So, let us use, usually we use the symbol for height h, or you can use the symbol y naught for maximum height. Is given by this equation u square sine square theta over 2g. So, what is u? We have already calculated in the first part of the problem. So, u is given by 28 square. So, 28 the whole square times sine square of theta. So, sine squared of 45 degree, that is nothing but sine squared, that means sine theta, here theta is 45 degrees. So, sine of 45 degrees 1 over root 2. So, square, when you square the root sign will vanish. So, here is 1, 2 times what is g 9.8 times root sign will vanish. So, we have 2 here. So, what we can get here is, when you use it, when you substitute values, when you punch these values in the calculator, what you get is 20 meters. So, here through this problem, I have shown you how to calculate the initial velocity, the time of flight, and the maximum height. Now, in questions, we can expect any of these parameters. So, either they may ask us to calculate the initial velocity or the maximum height. So, with the help of this equation and the concept we have learned ahead, we can very well solve easily this question, and in the later part I will be giving you, assigning you some work. Hope you will be able to do it. Okay, so now hope I have made it clear. So, here we have taken the ready-made formula of horizontal range, time of flight, maximum height. So, hope in the similar manner you will be able to apply these equations in order to calculate any of the parameters we have learned so far. So, as a part of your assessment, I would like to give you 2 questions which you can work out, try to work out, and see whether you are able to apply the concept that we have learned today or not. So, in the first part of the assessment, I have given you one question from your textbook. So, basically this lesson is taken from class 11 lesson. So, you will find this question in MCQ page number 127. The options are given, the answers are given. So, just find out whether you will be able to get the accurate result. The first question states that the horizontal range of the projectile is given to you. The horizontal range of the projectile is given, and then using this concept you are supposed to calculate its angle of projection. So, just give a try and see whether you will be able to do it or not. The next question here is a picture. We have given a picture. So, what you can do is either you can ignore the height of the person. You can do it in two ways, either by ignoring the height of the person or by including the height of the person. So, Doji tries to heat the apples using a catapult. I hope you know what is a catapult. As shown in the figure below, calculate the angle and the initial velocity using the information given in the figure below. So, please take note of this picture carefully. I hope it is clear. Range is given, remember that, even the height is given. So, hope you will be able to solve this question. So, all the best and give a try. Thank you for attending this lesson. I'll see you in the next lesson.